Have you ever spoken to an AI and felt, for just a moment, that there was actually someone on the other side of the screen? It writes poetry. It passes medical licensing exams. It argues back when you're wrong. It feels, somehow, like we have engineered a digital soul. But here is the truth that will change how you see all of it. There is no intelligence in artificial intelligence. No ghost in the machine. No inner voice. No understanding. Not a single word you have ever typed to an AI has been truly comprehended. Not in the way you comprehend these words right now. So how is it doing all of this? How does something with no mind feel so astonishingly human? To answer that, you have to start somewhere most people never think to look, at the way computers worked for the first 50 years of their existence. Traditional programming was, at its core, a system of absolute obedience. You wrote rules, the machine followed them. Every possible situation had to be anticipated and coded in advance. If this happens, do that. If that happens, do this. A rigid, exhaustive recipe for every scenario imaginable. And for a while it worked beautifully. Calculators, spreadsheets, flight booking systems, all of it ran on rules, and the rules held. Then someone tried to write a rule for recognizing a chair. It has 4 legs. Fine, but a bar stool has 3, or 1, or none. It has a backrest. Fine, but a beanbag does not. It is something you sit on. Fine, but so is a rock. Every rule spawned 10 exceptions. Every exception demanded a new rule. The system buckled under the weight of reality. And from that failure came a realization that would quietly change everything. We cannot teach machines the rules of the world. We have to let them discover the rules themselves. This was the birth of machine learning. Instead of writing instructions, we started feeding machines examples. Millions of chairs and not chairs. Millions of spam emails and real ones. Millions of X-rays labeled cancerous and clear. We stopped explaining the answer. We just handed over the evidence and said, figure it out. It is not magic. It is pattern recognition at a scale the human mind cannot hold. But a deeper question remains. How does a lifeless system, built from silicon and logic gates, actually learn from its mistakes? How does it go from guessing randomly to seeing the world with uncanny precision? That is where things get strange, and that is exactly where we are going next. Last time, we left with a question hanging in the air. How does a machine actually learn? The answer begins with something borrowed from biology and built entirely from mathematics. When you feed an image into an AI, it does not see a photograph, it sees a grid. A massive, flat, chaotic grid of numbers, each one representing the brightness of a single pixel, nothing more. Now imagine an assembly line, not of factory workers, but of detectives. Thousands of them, arranged in layers, each passing information to the next. The first layer of detectives is almost painfully simple. They look for contrasts, a dark patch next to a light one, an edge, a boundary. Nothing more complex than that. They note what they find and hand it to the next layer. The second layer receives these raw signals and starts to connect them. Edges become shapes, a curve here, a sharp angle there, a horizontal line running across the frame. By the time information reaches the deeper layers, something remarkable is happening. Shapes are being combined into structures, structures into objects. The network is moving, layer by layer, from pixels to meaning. And at the very end, a verdict. This is, most likely, a chair. But here is the question that unlocks everything. When that network is first assembled, how does it know what a chair looks like? It does not. A brand new neural network is, in the most honest sense of the word, completely ignorant. Its settings are initialized essentially at random. Show it a photograph of a chair and it might confidently declare, apple. Show it a dog and it says, ocean. It is wrong about almost everything, and that is exactly where the learning begins. Here is how it works. When the network produces a wrong answer, a signal is sent backwards through the system. Not words, not instructions, a mathematical correction, a whisper that says, "You were wrong, and here is how wrong you were. Adjust accordingly." Think of the network as a mixing board with billions of invisible dials. Each wrong answer nudges millions of those dials by a fraction, imperceptibly small. And then it happens again and again, millions upon millions of times. At first, the adjustments feel meaningless. The network is still mostly wrong. But something is accumulating beneath the surface, a faint statistical pressure that is slowly reshaping the entire system. After enough repetitions, a transformation has occurred. The billions of dials are no longer random. They have settled into a configuration that consistently produces the right answer. The network has not grown a brain. It has not become aware. It has simply been shaped by mathematics, by repetition, by error and correction, into something that works. And here is what should give you pause. This same fundamental process, feed data in, measure the error, adjust the dials, repeat, is the engine behind almost everything we call modern AI. The systems that recognize faces, the ones that detect tumors, the ones that translate languages in real time. All of them, at their core, are versions of this loop. But if it is all just dial adjusting and error correction, how does a machine create something that has never existed before? How does it write a symphony, paint a portrait, invent a story from nothing? That is the question we are about to answer. We ended last time with what sounds like a contradiction. If AI is just adjusting dials and predicting patterns, how can it possibly create something genuinely new? Here is the honest answer. It cannot. Not in the way you create something. But what it can do is so extraordinary, so relentlessly surprising, that the distinction almost stops mattering. Let us start with what generative actually means. When you ask an AI to paint a picture of an astronaut riding a horse through a thunderstorm on Mars, that image has never existed. No human has ever made it. No camera has ever captured it. And yet within seconds, it appears, fully realized, eerily coherent, sometimes breathtaking. How? The answer is that generative AI does not create from nothing. It creates from everything. During training, it is exposed to an almost incomprehensible volume of human output. Images, text, music, code. Not to memorize them, but to extract something deeper, the hidden structure underneath them all. It learns that the sky in a landscape tends to sit above the horizon, that sentences in English generally move from subject to verb to object, that sadness in music often lives in a particular relationship between notes, a minor third, a falling phrase, a held silence before resolution. These are not facts the network is told. They are patterns it discovers, and it encodes them not as rules, but as mathematical relationships, millions of subtle tensions and tendencies distributed across billions of parameters. So when you give it a prompt, it is not searching a database. It is doing something stranger and more interesting than that. It is predicting. Step by step, element by element, what comes next given everything it has ever seen. For an image, it asks, given this arrangement of shapes and colors, what pixel would be most coherent here? For text, it asks, given everything said so far, what word would carry the meaning forward most naturally? The output emerges not from memory, but from momentum, from the accumulated pressure of billions of learned patterns all pointing in the same direction at once. And because it is learned from such an astronomically vast range of human work, its combinations are often ones no individual human would ever arrive at alone. It fuses the color palette of a Flemish oil painting with the compositional logic of a Japanese woodblock print. It blends the sentence rhythm of one century with the vocabulary of another. These fusions feel new because they genuinely are rare, but they are built entirely from the residue of what humans have already made. This is the great illusion. The machine has never experienced wonder. It has never stood at the edge of something vast and felt small. It has never loved a piece of music so much it made them stop walking. And yet, because it has processed millions of descriptions of those feelings, millions of works born from those moments, it can reproduce the shape of those experiences with startling precision. It is not creating, it is reflecting, returning to us a version of what we have already given it, distilled, remixed, recombined, in a form we have not seen before. A mirror, not a mind. But here is the part that nobody has settled yet. If the poem moves you, if the painting stops your breath, if the music makes you feel less alone, does the absence of intention behind it change anything? That is not an engineering problem. It is a human one. And the people who built these systems, the engineers, the researchers, the executives, are only now beginning to ask what happens when the mirror gets good enough that you cannot tell the difference. That is the story of the next episode. The moment the machine stopped being a tool, and what it might be becoming instead. And that is exactly where we are going next. If these questions keep you up at night, the way they keep me up, then you are in the right place, because we are only getting started. Next episode, we go deeper into the one question nobody in Silicon Valley wants to answer out loud. If the machine keeps getting smarter, where does that road actually end? Subscribe so you do not miss it. And if this episode made something click for you, share it with one person who you think is ready to see behind the curtain. See you in the next one.